the many worlds interpretation of AI and why induction actually can lead to AGI. David Deutsch has a very strong argument against induction. He uses the turkey, for example, or the sun rising as an example. So the turkey gets fed every day by the farmer by induction. He concludes, creates a theory that is very solid, says this farmer is benevolent, he likes turkeys, he particularly likes to feed turkeys very good food, healthy food, and then at Thanksgiving, the theory collapses, right? So that's why induction doesn't really work. My point is, in the many worlds theory of, or the many worlds interpretation of AI, which has been discussed before, I'm just going to very briefly summarize it. We have video generation, environment, unsupervised environment design. So we have a wide range of environments that agents can learn in through induction, in particular Solomon induction and Kolmogorov, and develop intelligence weighted by Kolmogorov complexity. Please refer to Mark Hutter's definition of intelligence for that. But what it means in plain English just means that if an agent can try and error through a very large, maybe not infinite, but definitely very, very large set of trajectories, it will eventually get to the point that David Deutsch calls creativity. So in the case of the turkey, it will go through many different worlds where the turkey doesn't get fed, where the turkey actually gets hunted down, and then it will realize that the world in which the turkey gets fed and then killed at Thanksgiving is a very small subset of the trajectories that embedded in real data. So we're not talking about some sort of Harry Potter type world, but real data, real experience. In a world like that, most likely the turkey will not be fed very well, and therefore the agent will realize that there's something wrong with that feeding and will avoid that type of feeding. So in that sense, it might not have an explanation until it actually goes through the experience. Excuse me. But most importantly, it will make a prediction and plan accordingly, and the prediction will be, in a sort of an evolutionary context, much more useful. In other words, the turkey will avoid Thanksgiving and therefore survive. Now, what does that actually have to do with AGI and David Deutsch? So first, I think most importantly, what these models will do is make the right predictions. And that's already pretty useful. Now, I can see a counter-argument here by Deutsch saying, well, science is not about predictions. Predictions is an emergent faculty from science. It's useful. We can create technologies. But we want to have explanatory power. Humans are universal explanators, and therefore we need to find explanations. So the turkey has to not just predict that being fed well is potentially scary, it has to have an explanation for why it's being fed well. Now, my point here is that in a many worlds interpretation of AI, what we are tasked to build is a universal representation of world models. So if we can build a machine that can represent many worlds and then have an agent learn by induction, by self-play in those many worlds, or potentially by continuous learning and self-play, which is what Richard Sutton is suggesting, then we will approximate this type of environment where the machine actually can not just make the right prediction, but from a summary of its stored experiences, potentially also make an explanation. I'm a bit wary about the universal explanator, but I think we can get to a point where we can have universal environment design, unsupervised universal environment design, UUED. So it's not just unsupervised design, but universal. So in other words, it can represent any environment which is permitted under the laws of physics. And in that context, it can then have the agent iterate. Now, of course, that is bounded by compute and power, And there's many questions related to that. But in principle, that's how we're going to get to universal artificial intelligence. Thank you.